5.3, Evaluating Trigonometric Functions. So we already know all 6 of these. So get all 6 of these things copied down, but it's just your 6 trig ratios. Sine goes with y, so y over r. Cosine goes with x over that kind of thing. Now example 1, it kind of uses the trig ratios, but since it's off in space, it's really more of a SOHCAHTOA question. So on this one, you would probably want to go back in time to geometry and remember your SOHCAHTOA. All right. Example 1 says find sine, cosine, and tangent for angles A and B. Well, what I would do if I were you is first identify the angle. If you don't identify the angle, then you're going to have a hard time finding the side opposite that angle. All right. So when I do sine of angle A, it doesn't really make sense to look at y over r because we don't know what the x and y coordinates are. We're not in a coordinate plane. Notice this says in standard position. That's talking about when we're in a coordinate plane. Okay. If we're not in a coordinate plane, it's probably more something like this where we're using SOHCAHTOA. So we need to go back and think about opposite over hypotenuse. Well, if I'm looking at A, the opposite side is 7, and the hypotenuse is 25. So if I do opposite over hypotenuse, it's just 7 over 25. So then cosine A, don't forget your angle. Don't forget to write that A in there. It would be wrong if you did. Cosine is adjacent over hypotenuse. So adjacent means next to. That's this 24. It's going to be 24 over 25. And then tangent A, we know tangent is opposite over adjacent, so the opposite side is 7, the adjacent side is 24. There you go. Now if we wanted to do angle B, again, you have to kind of zone in on angle B so you can identify which side is which. If we go to sine B, sine goes back to opposite over adjacent, so if we're looking at the opposite side, it's now 24. I think I said adjacent, but I meant hypotenuse. Opposite over hypotenuse is going to be 24 over 25. Then we're looking at cosine. Cosine, whoops, not of angle A, but of angle B. Cosine of angle B. Cosine is adjacent over hypotenuse, so 7 over 25. And then tangent B, we know tangent is opposite over adjacent, opposite 24, adjacent 7. That's it. Now, cofunctions, okay? Cofunctions is something that students really struggle with, but you shouldn't, all right? Basically, when we're talking about cofunctions, think about sine. That's actually how you spell sine. And its cofunction is literally just cosine, all right? Cofunction, cosine. So there's sine and cosine, there's secant and cosecant, there's tangent and cotangent. So cofunctions are literally just the function that you put a co in front of, all right? Cofunctions. So the angles have this certain relationship. Sine of something, so I'm going to say sine square equals cosine triangle, all right? Now there's a relationship between whatever those angles are, whatever those numbers are, under the square and the triangle. But it's the same for each of the sets of cofunctions. Tangent square equals cotangent triangle, and secant square equals cosecant triangle. Okay, so here's the relationship. The relationship for cofunctions, square plus triangle equals 90. Okay? Square plus triangle equals 90. That relationship exists for cofunctions. So for example, if you could calculate sine 30 degrees you should know that that would be equal to cosine of 60 degrees. Notice those two numbers. Notice what those two numbers do. Those two numbers add up to 90. Square plus triangle equals 90. So if I said tangent 40 degrees, tangent 40 is equal to cotangent of what? 50 degrees. That's correct. All right, that's it. That's all there is to that concept. Now, students really struggle with that. I think it's because they're thinking about reciprocal identities. You know how sine is the reciprocal of cosecant? That's a completely different relationship, so don't get that confused with cofunctions. Okay, sine and cosine. So example 2 is really straightforward. Write each function in terms of its cofunction. Think about square plus triangle equals 90. All right, cosine 52 degrees is going to equal sine of, basically you have to do 90 minus 52, 38. Okay, those two numbers have to add up to 90. And tangent 71 is going to equal cotangent of what? 19, right? Because, I mean, you know this because 52 plus 38 equals 90. And 71 plus 19 equals 90. That's it. Square plus triangle equals 90. So secant 24 is going to equal cosecant 66. All right. 90 minus 24 is 66. Okay. Now, that's not that complicated of an issue, but when people get here, trust me, this is one of the most commonly missed test questions. Find one solution for the equation. Assume all angles involved are acute angles. Okay? People see something like this, and what they want to do, which is incorrect, is they want to just cross this out and say, oh, well, x plus 4 equals 3x plus 2, and that's not what this says at all. Okay? These two things are cofunctions. Sine and cosine are cofunctions. So you have to remember that square plus triangle equals what? 90. So what you would do here is take square plus triangle equals 90. Not a hard thing to do at all, but a lot of people just won't study and won't prepare and won't get it. So combine like terms, you get 4x plus 6 equals 90. I can subtract 6, that's going to be 84. Divide by 4 on both sides. X equals 21. So let's do it again. Notice you have cofunctions. Okay, so this thing plus this thing equals 90. Combine like terms, that makes 3a. The 18s just fall out. 3a equals 90. Divide by 3, you're going to get a equals 30. Not very hard, but it's very commonly missed. Special triangles. You're supposed to notice in a 30, 60, 90 right triangle that there's this pattern of 1, 2, and oops, it's supposed to say square root of 3. 1, 2, square root of 3. That's a special pattern that comes up and repeats itself and allows you to solve other problems that kind of look like that. Okay, and so how this pattern works is you would identify the short side, okay, and you can tell the short side because it's across from the smallest angle, all right? And the relationship that I notice is the hypotenuse is always double the short side. So what's going to happen is you're going to see this side is going to be like 4, let's say. And so that would tell me that the hypotenuse is 8 because that relationship is like a proportion, okay? 1 is to 2 as 4 is to 8. And so you can see this relationship, and then this longer side, this longer leg of the right triangle, has that relationship. 1 is to square root of 3 as 4 is to, and then that would be 4 square root of 3. So I think of it as just multiply by square root of 3, but that's your pattern, okay? That's going to repeat itself over and 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 over, okay? If that was 7, then this would be 14, and this would be 7 times the square root of 3. As soon as you learn that pattern, you're going to be good at these, you're going to be faster at these. Then there's this other, a 45, 45, 90 right triangle, and it's 1 square root of 2. Make sure you put the square root in there. It doesn't work otherwise. And so that was a little bit easier, I suppose. If this side was 8, then you would know this side is the same thing, also 8, and this side would be 8 times the square root of 2. So you're going to look at some examples, and examples are going to be something like this, okay? So the first one, find x and y. I'm looking at a 30, 60, 90 right triangle, and to notice they give me the short side, 12. The small side is 12, and I can tell that because it's across from the 30, the smallest angle. So the easiest thing to do is to look for the hypotenuse and understand that that's going to be double. That's 24, x is 24. And then you look at the longer leg and understand that that's just going to be the shorter leg times the square root of 3. So there we still have our pattern of 1, 2, 3. 1, 2 square root of 3. The next one is a 45, 45, 90. And we've got one of the legs, so that means that this other leg would be the same thing, 15. Has to be. Because it's an isosceles triangle, those two legs have to be the same. There was a theorem back in geometry class that if those two are the same, then those two are the same. That's basically what you're using. Now you could do Pythagorean theorem to find that missing x side, but I know my pattern is 1, 1, 2, or 1, 1 square root of 2. That means this missing side is 15 times the square root of 2. Now, the next one's a little bit more complicated because there's more going on, but it's still the same exact concept. Where I would probably start is with this smallest triangle because the number 6 is there. So I see a 60-degree angle, and I can deduce that this one is 90. And then if you've got a 60 and a 90, then this other side must be 30. So I am looking at a 30, 60, 90 triangle. Not only that, 6 is the smallest side. So if I know that's 6, then I would know this hypotenuse is 12, and this long leg would be not 12. This is 12. This is 6 times the square root of 3. It's always the short leg times the square root of 3. So I've got my 1, 2, 3 pattern going on. All right. So there are a couple of different ways to use this information. Okay. One way is to look at a different triangle. Look at this triangle, the second triangle, and see that you've got the short leg, 6 square root of 3. So you could double that and find the hypotenuse. So if I double that, I think 6 square root of 3 times 2. I should be able to do that in my head. That's 12 square root of 3. So y equals 12 times the square root of 3. Now x, okay, you take the small side, 6 square root of 3, and multiply times square root of 3. That's 6 times 3 is 18. Okay. Now that's not the only way of doing it. If you go back before we had the red and you just look at the green, okay, that side 12 is actually the short side of this largest triangle. This largest triangle has a 90-degree angle right there, and a 60 and a 30. So that blue one is also a 30, 60, 90. So if you think about it, you've got the short leg. This hypotenuse would be double that, which would be 24. Okay. Now notice this is 6, so then this x must be 18 in order to make the 24. 6 plus 18 is 24. So we're still going to get x equals 18, and then this side over here, you would just take that short leg times square root of 3. So there's a couple of ways of getting to that answer, but there it is. Function values of special values. This is the chart, okay, and this is going to be really, really important for pretty much the rest of the semester. So get these numbers down. What's going to happen, though, is you're not going to want to memorize all of them. You're probably only going to see this, and in fact, you probably see this poster hanging up in the room of these 2 rows of the chart. Honestly, it might help if you could memorize the entire chart, but I hate memorizing, so I'm not saying you probably should, only that it might help. All right, this will come back. So I'm going to change gears here. In order to do some of these problems, we're going to have to do something with the reference angle. A reference angle for an angle theta is the positive acute angle made by the terminal side of angle theta and the x-axis. It's really important that you make this angle with the x-axis. Okay, so check out what we're looking at here. All right. So we've got some angle here, theta, that's putting me into the second quadrant. I don't really care about that. What I care about is the distance from the x-axis. Okay, that's what this says right here. We're talking about the reference angle, is how far it is from the x-axis. Okay, so pay attention to that. That is going to be the reference angle right there. And so then the next picture, you've got this angle that puts me into quadrant 3. But again, I really only want to pay attention to how far away it is from the x-axis. That's going to be the reference. And here's an angle in quadrant 4. I only care about how far it is off the x-axis. That's going to be your reference. That's going to be really, really important. So example 4a says find the reference angle for 218 degrees. If I'm going to do that, I want to picture where it is. And so you need to memorize these numbers, 0 and 90 degrees and 180 degrees, 270 degrees, and all the way around is 360. So if you're looking at 218, 218 is going to put us in the third quadrant somewhere, right? Third quadrant, that's 218, okay? But if we're finding the reference angle, what I want to know is I want to know this distance right here. And once you get good at this, you'll do it in your head, and you'll see it's just how far past 180 are we. With a calculator, I guess, you could go 218 minus 180. But again, when you get good at this, you're going to be doing this in your head. The reference angle right here is 38 degrees. Okay, 38 degrees. The next one, I want to subtract 360 a few times because basically I just want to know where this is. Once I get down to the least positive coterminal is 307, that's good for me because I know where that is. I can picture that. I know all the way around is 360 and right here is 270. So 307 must put me in the fourth quadrant somewhere. And so does 1387, but 307 is just easier for me to picture. Either way, I don't care because what I really need is this angle right here. I need to know how far from 360 that is, basically. So your math would be 360 minus 307. But I care about this right here. That's going to be 53 degrees. So your reference angle would be 53 degrees. That is going to be insanely important that you can do that. So how we're going to use the chart. Find the reference angle. 2, find the trig function values for that reference angle. Determine the correct signs of the values. Okay. So find the values of the 6 trig functions for 210. What that means is we want to find sine 210 degrees, cosine 210 degrees, tangent 210, cosecant 210, secant 210, and cotangent 210. That's what we're trying to find. Okay? If you go back to the steps, it says step 1, find the reference angle. So we've got a 210 degree angle, so think about where that is. That's terrible. 210 degrees, remember here's 180, and here's 270. So 210 is going to put me into the third quadrant. Third quadrant. Okay. And what you want is to look for how far it is off of the x-axis. So basically, you're going to do this in your head. How far is 210 away from 180? That's 30 degrees. Okay. So we're going to treat our 210 degree angle kind of like a 30 degree angle. But what we have to do is we have to consider what happens to that angle in the third quadrant. So remember when we did all students take calculus? Which of the 6 trig functions are positive in the third quadrant? Tangent and cotangent. So of the 6, I know that tangent and cotangent are the only ones that are positive. The rest of them are negative. All right? So really, that's step 3, determine the correct signs for the values. I'm kind of going out of order. I did step 1, step 3, step 2. But what I'm going to do is really just look at a 30-degree angle. So I know that in the third quadrant, it's going to be negative whatever sine 30 was. So if you go back and look at this chart, sine 30 is right here. Sine 30 is 1/2. Sine 30 is 1/2. So what we're going to have is negative 1/2. Sine 210 degrees is negative 1/2. And cosine 210 is going to be negative cosine 30. Let's go ahead and fill all those out. Tangent 210 is going to be positive tangent 30 degrees. And cosecant 210 is negative cosecant 30 degrees. Secant 210 is, secant 210 degrees is negative secant 30 degrees. And cotangent is going to be positive cotangent 30 degrees. So we know which ones are negative and which ones are positive. So just look back at the chart, all right? So again, I don't know that you want to memorize this chart, but here's cosine 30, here's tangent 30, and so we just fill in those values. So cosine 30 is square root of 3 over 2, so cosine 210 is negative square root of 3 over 2. And we're going to have positive tangent 30 here, so that's going to be positive square root of 3 over 3. And cosecant 210 is negative cosecant 30. What was that in the chart? Cosecant 30. Okay, so you're looking at a 2. And is it negative? Yeah, so it's negative 2. And secant 30, go back and look at the chart. Secant 30 is this thing, but I believe it's going to be negative. Yeah, negative 2 square root of 3 over 3. And then cotangent 30. Go back and look at the chart. Cotangent 30, straight from the chart. Square root of 3. Okay, so those are your answers. Those are the values of the 6 trig functions for 210 degrees. Example 6, find the exact values of these things. So sine 150 to start with. I think what you want to do is you want to draw it. Just imagine, okay, imagine where this is. And so I know 180 is right there. 150 is going to put me in the second quadrant. Okay? The reason I'm drawing it is because I want that reference angle. That reference angle is how far away from the x-axis we are. So you look at it and you say, how far away is 150 from 180? And you should be able to do that in your head and figure out that that's 30 away. All right, so that's your reference angle is 30. So what you're going to do is you're going to turn the 150 into a 30 and deal with it that way. But you've also got to think about being in the second quadrant. The fact that we are in the second quadrant tells me something about the sine function. What do we know about sine in the second quadrant? It's positive. Very good. So we know this is going to be positive whatever sine 30 is. Okay? And so you can look at your chart, look back at that chart that you have, and find sine 30. Sine 30 is 1/2. This is going to be positive 1/2. All of the problems work pretty much that same way. Okay? 225, I would try to imagine where that is. So we've got 180 is right here, and 270 is downstairs. So if I'm looking at 225, I know that puts me in the third quadrant. The reason that's important is because, remember, all students take calculus. I know tangent is positive in that third quadrant. So I look for a reference angle. And basically that's how far away from the x-axis am I. So if you need a calculator, you can do 225 minus 180, but you need to get to where you can do that in your head. That's 45. You're going to see the same numbers over and over and over again. That's 45. So it's like we've got a positive of whatever tangent 45 degrees is. So again, you go back to the chart, tangent 45, straight out of that chart, tangent 45 looks like right there is 1. So we've got positive 1. Cosine negative 240. Now that negative does not mean the answer is negative. It means we're going around backwards. So that's 0. And if we go backwards, that's negative 90, negative 180, negative 270. So if I'm going around backwards, negative 240 puts me in quadrant 2. What do I know about cosine in quadrant 2? Cosine is negative. Cosine is negative there. So we look for a reference angle. Reference angle is how far away from 180 are we? Or in this case, negative, I guess. Negative 240 is 60 degrees away from negative 180. And so essentially, I'm just looking at cosine 60. I've got negative cosine 60. So you look at the chart and find that cosine 60 is 1/2. You see that negative, you know it's going to be negative 1/2. Okay, now keep in mind, we did not find the value of cosine 60. Okay, we found the value of cosine negative 240. And the reason that this answer is negative is because that put me in the second quadrant. We just used 60 to get us there. Cosine 180. So we know 180 is going to put us right there. Okay, so it's kind of tricky for some to think about how far away from the x-axis that is, but it's right on the x-axis. 180 is 0 away from 180. All right. We also know about cosine. Cosine, you can't really say that's the second quadrant because it's in between 2 and 3. So I wouldn't call it in a quadrant. But regardless, I know cosine is going to be negative over there because the x numbers are negative over there. So this is going to be negative. And since we're 0 away from the axis, it's the same thing as negative cosine 0. So again, go back to the chart. Cosine 0 is 1. You're going to have a negative 1. Cosecant 315. I know 270 is right there. All the way around is 360. So 315 puts me in the fourth quadrant. Fourth quadrant, cosecant. Let's see, all students take calculus. I know cosine and secant are positive there. That means this must be negative. Cosecant is going to be negative in the fourth quadrant. And so I find that reference. You're basically asking how far is 315 from 360, and you're going to see that's 45. So we're looking at negative cosecant 45 degrees. I don't really care about 45 degrees other than it's easy for me to find in my chart. Cosecant 45 degrees is right there, square root of 2. So my answer is going to be negative square root of 2. Cotangent 240. This is 270, so I'm just short of that, I guess. 240 is right there. You want to see how far away that is from the x-axis? Never the y, always the x. So if that's 240 and 180, you're comparing it to 180, that's 60 degrees away. Okay, so remember, all students take calculus. We know tangent is positive there, so that means cotangent would be positive there as well. So we look at our reference angle of 60 degrees and say it's positive cotangent 60 degrees. Here's the chart, cotangent 60 degrees, square root of 3 over 3. We are at Positive square root of 3 over 3. All right, now I am on a roll. It's got one more slide. Okay, example x3, it's basically a PEMDAS question. Okay, so you got cosine 120 plus 2 sine squared 60 minus tangent squared 30. Okay, and keep in mind when it says sine squared 60, you don't want to need to write this down, but that's the same thing as sine 60 squared. All right, so that's really what we're looking at when I've got that square. Okay, so I'm going to go to sine 60 first because it's straight out of the chart. Sine 60, straight out of the chart, the square root of 3 over 2. And tangent 30, straight out of the chart, square root of 3 over 3. 120 wasn't in the chart, so that's why I'm going to have to do the reference angle on that one. Okay, so reference angle, 120 puts me over here in the second quadrant. 120 is 60 away from 180, so basically I want to do a cosine 60. But wait a minute, what do we know about cosine in the second quadrant? It's negative. So negative cosine 60, that's negative 1/2. And that's what's going to go right there. Okay? So now all we've got is order of operations. Okay? Order of operations. I'm going to square this. Square root of 3 squared is 3, and 2 squared is 4, so I've got this fraction. And likewise over here, let's do this. Square root of 3 squared is 3, and 3 squared is 9. So look what we have. Negative 1/2 plus 2 times that minus that. Okay? It's just algebra here. 2 goes into 4 twice. So I have negative 1/2 plus 3/2 is 2/2. And then I can reduce this to 1/3, so minus 1/3. That looks like 1 minus 1/3. The answer is 2/3. Okay? Second part, same as the first. Oh, wait, I don't want this to be sine. I want this to be cosine. So change that. Make that a change. Otherwise, it's kind of a nasty number. 4 times something plus 10 times something squared. So let's look at cosine 120. Didn't we just do cosine 120? We just did cosine 120 and got negative 1/2, right? That was negative 1/2 just a second ago. Cosine 315. 315 puts me into the fourth quadrant. Okay? I know cosine is positive there. Your reference angle is 45, so that's going to be positive cosine 45 degrees, or square root of 2 over 2. At this point, it's just order of ops. I'm going to square this. Square root of 2 squared is 2. 2 squared is 4. 4 times negative 1/2 is negative 2 plus 10 times this. That's 10 times 1/2, right? 10 times 1/2 is 5. So we have negative 2 plus 5 equals 3.